We're currently in building 56B, which is the C4D lab space in the front workshop or the traditional workshop space. When the students come and do their design thinking course, the part of the module is prototyping. So they will come over to the lab space, both this one and the other lab spaces, and they will take their idea from the ideation stage and turn it into a prototype and then potentially into a fully fledged product at the end. So in this lab space we split it into two sections. In the section to my left we have our hands-on prototyping space, and then in this end we have all our CNC capabilities. So that's where you've drawn your part on a CAD-based program on the computer, and then we can generate it into files that these machines read, and we can get accurate parts made out of them. Allowing the student to take their idea from a sketch or just a thought in their mind, allowing them to turn it into a physical, hands-on object, allows them to get an appreciation for how these processes work. It's all right, well and good designing something on a computer, but with having no idea of how this thing's going to turn into reality, allowing the students to work in this workshop space allows them to see that and get an appreciation for how parts are manufactured. It allows them to change potentially the way they think about design, that it isn't just drawings, it is the whole process, it encompasses everything. It allows them also to potentially change their mindset so that they're subconsciously thinking of how this thing's going to be made as they're designing it up on a computer, or talking about it to another person or individual. They can say it's made by CNC milling or lathe work, or we're going to injection mould it or something like that, whether it be for the prototype stage or for the end product stage. The industry will have much larger versions of these, but the principles that are learned through using these pieces of equipment will translate pretty easily to industrial equipment. In this workshop space we have a Boxford A1 Hspi plasma cutter. It's an 80 amp one, so it can cut up to 20 mil thick mild steel. It's predominantly used for cutting out rough shapes of flat metal material, because it's using an arc technology rather than a laser, so your precision is going to be slightly less, but it allows you to prototype large parts relatively quickly, and then you can do your hand finishing down in the other end of the workshop. The machine behind me is a 300 Vmc milling machine. It's basically a traditional mill, but this is a CNC version of it. It's got an 8-tool changer, which you would have in industry, but those would be on a much larger scale than this. It's predominantly used for metalworking, but it can also be used for hard plastics. Our Cnc Lathe, also from Boxford, predominantly used for metalworking and turning of metal parts, also used for plastics, but in this case it's mostly metal. We normally use Solidworks as our computer-aided design software. So when a student comes with us with a design, it's then converted into a file format, which is then inputted onto these machine software. This is then converted into a G-code file, which these machines read and then follow through that, which gives the tool its position in X, Y and Z. Once the induction weeks have all been done through the course and they've done their first prototype module, group projects and individual thesis projects, the students are able to use all of these pieces of equipment along with everything else we've got in these lab spaces. And we also have individuals that come from other departments around the university that also use our facility spaces, or we produce parts for them using pieces of equipment.
This is the laser cutting room. It was designed originally for a lot of woodworking things and more soft materials, foams and plastic cutting. So this is a Universal Systems laser cutter. It takes sheet material and uses a laser to cut it. It's really useful for very intricate, quick prototyping. You could even cut small gears. It will cut most plastics, small bits of wood, softer material, any non-metallic. It will cut quite well. First step is obviously designing your part in Solidworks. The parts can then be turned into a 2D line drawing or DXF style file. We can then load that into the software on the laser cutter and set it up. You put your sheet in, you set your focus length, so basically just how far away the plastic or the material is from the end of the laser beam, and then press go, and usually within a couple of minutes your thing is finished, if not quicker. Laser cutters are used in industry. You can get more powerful ones than we have here that will cut up to usually around 10mm thick aluminium sheets. We also have the plasma cutter next door to do large rough cuts for things like that. Laser cutters are also absolutely brilliant for engraving and etching logos and things. Part numbers, so a lot of big companies will actually have a laser cutter, a laser etching device, not specifically a cutter, that will do batches of part numbers, serial numbers onto parts, metalwork, things like that. So they're widespread throughout industry.
We're now currently in C4D/3D print. This is where we keep all our FDM printers. We've currently got just around 30 of them, but hopefully expanding further. The facility in its current form has only been set up for just over a year now, but C4D's had a interest and an expertise in FDM printing for the past five or so years. The facility's been opened up to the rest of the university as a general term. It can be students, staff members, and we're also potentially opening up to external people. We've been doing ad hoc work for different departments for many years now, but it's now a case of we've expanded further, so we'll get more visibility within the university, and this becomes a pan-university offering that we can produce parts for water science, into composites, into aerospace. There's a plethora of opportunities for it, or it could be simply somebody's got an idea and they've sent a model over and we print that for them. Design thinking students would be introduced to this facility in their induction week and then get proper use of it during their prototyping module. After that point, they're more than welcome to come over and use these facilities to produce general ideas that they've come up with, whether that be group project, individual thesis, or just individual idea. We're more than encouraging of that within C4D. So in order to access and use this facility, a student will bring their design that they've made in Solidworks or another CAD package, and they'll export it normally as a .stl file, which is a stereolithography file. We then take that file and run it through a slicer software which produces the G-code that the machines read. So that gives you the instructions of where the nozzle is in X, Y and Z. So using either the tethered machines on the table behind me or these machines that run off of SD cards, they'll bring their file to the printer and then start the printer going. So the machine will then take the raw filament that comes in on spools, either 1.75 or 2.85 millimeters in diameter, and then the nozzle will heat up and it will be extruded out of that, producing a layer on layer part in these FDM technology. Times average from about an hour to our longest print so far, which was just over 3 days. So using these FDM printers, you can pretty much print most things in terms of prototypes, and you can produce parts that can be used at the final product stage. This facility has allowed us to interact with industrial partners such as the Bill and Melinda Gates Foundation, working on the Reinvent the Toilet Challenge. We're also working with a company called Garendale, who deal with train rolling stock. We've also done work with Safran, who design seats for aeroplanes, and we've done previous work with Procter & Gamble. In current times, in the COVID-19 crisis, this facility has allowed us to produce parts for breathable face shields that had filter units on it, so we produced some of those for local businesses. And then after that point, we produced some ear savers of the surgical masks that you place around the back of your head to save your ears getting sore from wearing these things. So we produced just over 500 of those in just under a week that were donated to Milton Keynes University Hospital. So we can operate by individuals sending over files to us. They tell us the specification of what materials they want, quality level, and we'll print the part and then contact them when it's printed. We're also going through the process of offering training courses for anybody that wishes to get into 3D printing. On offer with our printers, we have developed into a print farming facility, so we have multiples of these smaller printers that you see behind me, so we can produce large parts that are split into smaller sections relatively quickly with fast turnarounds. In terms of full single piece parts, we have 2 printers currently that have a build volume of 600mm by 1200 by 600mm, so we can print relatively large parts as a single piece. So the largest we've done so far is a cowling for an aeroplane jet engine which was used in the wind tunnel tests.